Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on Simultaneous Equations. And we're going to be dealing with simultaneous equations with three unknowns. If you need extra help on solving simultaneous equations with three unknowns, if you go to Corbettmaths and go to the videos and worksheet section, and scroll down to video number 393, there's a dedicated video tutorial there on three unknowns. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, we've been asked to solve the simultaneous equations x minus y plus 3z equals 5, x plus y plus 6z equals 12, and 3x minus 2y plus 2z equals 10. Okay, so we want to solve those simultaneous equations. So the first thing I'm going to do in a question like this is I'm going to number them. I'm going to number that one, equation 1. I'm going to call that one equation 2. And I'm going to call that one equation 3. Just so that whenever I'm dealing with this question, I can sort of keep track of what we're doing as we go through. Okay, so we want to eliminate one of the variables. Now, if we have a look here at equation 1 and equation 2, I'm actually going to eliminate the y's. The reason is here we've got minus y and we've got y. So that means if we add equation 1 and equation 2 together, that'll cancel out the y's. So let's do that. So let's do equation 1 plus equation 2. So equation 1 is x minus y plus 3z equals 5. Equation 2 is x plus y plus 6z equals 12. And we're going to add those equations together to eliminate the y. So let's do that. So let's add those two equations together. Now I'm going to write add here. Rather than just putting a plus sign, I'm going to write the word add, because if it was subtract and I just read a minus there, I might get confused and I might think it's x and minus x rather than equation 1 subtract equation 2. So I'm just going to write add there. And let's add these equations together. X plus x is 2x, so that's great. Minus y plus y, well, that's going to be 0, because if you've got minus y and then you add a y, you're going to get 0. Then in terms of the z's, we've got 3z plus 6z, that's equal to 9z, so plus 9z, so plus 9z. And then equals 5 plus 12 is equal to 17. So that's fantastic. We've now got an equation with no y variable in it. So I'm going to number that one equation 4. So that's one equation without y in it. Let's find another equation without y. Now we've used equation 1 and equation 2, so we want to use equation 3 this time. So equation 3 has got minus 2y. So if we have a look here at equation 2, if we double that, we'll get 2y. And minus 2y plus 2y is equal to 0, so that'll eliminate the y's, that'll cancel out the y's there. So I'm going to double equation 2, so I'm going to do 2 times equation 2, and 2 times equation 2 is equal to 2x plus 2y plus 12z equals 24, just doubling everything in that equation. Now I'm going to write equation 3 beneath it, plus 2z equals 10, so we've got equation 3. And now we're going to add these two equations together, because that'll eliminate the y's. So let's do that. Let's add those two equations together. And I'm just going to write the word add there, just so that we remember that we're adding the equations together. So 2x plus 3x is equal to 5x. 2y plus minus 2y is equal to 0, because if you've got minus 2y and you add 2y's, you get to 0. That's what we wanted. We wanted to eliminate those y's. Then our z's, we've got 12z plus 2z, that's equal to 14z, so plus 14z. And finally, we've got 24 plus 10, and 24 plus 10 is equal to 34. So that's fantastic. And let's label that equation 5. So that's equation 5. So we've got 2x plus 9z equals 17, and we've got 5x plus 14z equals 34. So that's fantastic. We've got two equations without the variable y in it. They've just got the variables x and z. Okay, now let's solve those like we would our normal simultaneous equations with two unknowns that you've probably looked at loads in the past already. Okay, so in terms of these equations, we've got 2x and 5x, and we've got 9z and 14z. So I'm thinking here the x is maybe a bit easier to cancel out here, because we've got 2x and 5x. So what I'm going to do is I'm going to times equation 4 by 5. So I'm going to do 5 times equation 4, and I'm going to write down what that is. So 5 times 2x is 10x. 5 times 9z would be 45z, so plus 45z. And then 5 times 17 is equal to 85, so that's equal to 85. So we've got 10x plus 45z equals 85. Now we've got our equation 5. Now we want to have 10x here, so I'm going to double equation 5. So I'm going to do 2 times equation 5. So I'm going to double everything in equation 5. So doubling everything there would give us 10x, again, which is great, plus, and then 14z doubled would be 28z. And then 34 doubled would be equal to 68. So that's fantastic. So we've now got our two equations. Both of them have got 10x, so we can now subtract them. And if we subtract those two equations, that'll get rid of our x's. So let's subtract them. And again, I just wrote a sub there rather than putting a minus sign, just so I don't get confused. Remember that I'm subtracting the whole thing. So 10x take away 10x is 0. 45z take away 28z is equal to 17z. And then 85 take away 68 is equal to 17. Oh, so that's fantastic. We've got 17z equals 17. We can divide both of them by 17 and we get that z is equal to 1. So that's fantastic. So now we've got z is equal to 1. Let's substitute that into either equation 4 or equation 5 and find out what x would be. So I'm going to choose equation 4. So I'm going to sub z equals 1 into equation 4. So let's do that. So if we substitute 1 in here, we're going to get 4z. We're going to get 2x. That's going to stay as it is. Plus. And then 9 times 1 is 9. And that equals 17. Then if we take away 9 from both sides of this equation, we get that 2x equals 8. And then if we divide both sides by 2, we get that x equals 4. So that's fantastic. We now know that z is equal to 1 and x is equal to 4. Now let's substitute those into either equation 1, 2, or 3. Now I'm going to choose equation 2. So we're going to sub, I'm just going to write that down, x equals 4 and z equals 1 into equation 2. So let's do that. So equation 2 is x, well, x equal to 4, so you're going to have 4. And then we've got plus y, well, that's still y. And then we had 6z, well, 6 times 1 is equal to 6, so plus 6 is equal to 12. So that's fantastic. We now solve this equation. 4 plus 6 is equal to 10, so we have 10 plus y is equal to 12. And then if we take 10 away from both sides, we get that y is equal to 2. So that's amazing. We now have that x is equal to 4, the y is equal to 2, and we've got the z is equal to 1. And that's fantastic. So there are solutions. And just before we finish and just write those down, I like to check our answers just to make sure we know that we're completely right here. So I'm going to substitute those into equation 1. So I'm going to sub into 1, so into equation 1 to check our answer. So equation 1 was x minus y. I'm just going to make sure we've got the whole equation here. Plus 3z, so plus 3z equals 5. And let's see if this is right. So x, that's 4. Take away y, that's 2. And then plus 3z, well, 3 times 1 is equal to 3. And does that equal 5? Well, 4 take away 2 is equal to 2, plus 3 is equal to 5. So we get 5 equals 5. And that's right. So that's amazing. We know those answers are right. And that's the great thing with simultaneous equations, and particularly these questions with simultaneous equations with three unknowns, is that you can actually check your answers and know that whenever you write them down, that they're right by just going back and checking. And that's it. So we were asked to solve those simultaneous equations, and the answers are x equals 4, y equals 2, and z equals 1. And that's it. Okay, let's have a look at our next question, question number 2. So question number 2, we've been asked to solve the simultaneous equations 2x plus 3y plus 5z equals 21, 3x plus 6y plus 15z equals 51, and 5x plus 4y plus 10z equals 37. Okay, so let's label the equations. That's equation 1, that's equation 2, and that's equation 3. And let's have a look and see which variable we're going to eliminate. So I'm noticing here that if we double equation 1, we'll get 6y. And then we've got 6y here in equation 2. So let's double equation 1. So let's do 2 times equation 1 and write down what that is. So if we double equation 1, we're going to get 4x plus 6y plus 10z equals 42. And then we find that by just doubling all the terms in equation 1. Okay, now let's write down equation 2. So equation 2 is 3x plus 6y plus 15z, and that's equal to 51. And then if we have a look at our y's, we've got 6y's and 6y's. If we take them away, that'll be equal to 0. So let's do that. So let's write here sub for subtract, and then subtract those equations. So 4x's take away 3x's, that's just x or 1x. 6y take away 6y, that's 0, so that's fantastic. Then we've got 10z take away 15z, so that'll be minus 5z's. And then finally, we've got 42 take away 51, that's equal to negative 9. So that's fantastic. We've now got an equation just with the variables x and z. There's no y variable in that equation. So that's great. We've eliminated one of the variables. And I'm just going to label that. I'm going to label that equation 4. Okay, so we've now eliminated y from these two equations. Now let's have a look and see how we can use equation 3 along with either equation 1 or equation 2. Okay, so I'm looking here at the 6y and the 4y. I'm thinking we could get 12y's. If we doubled equation 2 and multiplied equation 3 by 3, because that would give us 12y, then we'd have 12y's in both of them. So let's do that. And I'm just going to change color of ink here just so we can see what we're doing. And I'm just going to go up here. So if we double equation 2, we're going to get, so if we do 2 times equation 2, that's equal to, if we double everything, that'll be 6x plus 12y plus 30z equals 102, just doubling everything in that equation. And then if we times equation 3 by 3, so 3 times equation 3, so 3 times equation 3, and that's equal to, if we times everything here by 3, we'd get 5x times 3 is 15x, then 4y times 3 is 12y's, then we've got 10z's times 3, that'll be plus 30z. Actually, that's fantastic. We've actually got 12y and 12y, and we've also got 30z and 30z. You're going to see here we can actually cancel out both the y's and the z's here. And then if we times 37 by 3, that's equal to 111. So that's 111. So that's great. So we've now got two equations where we wanted to get the y variables to have the same coefficients. So here we've got 12y's and 12y's. That's fantastic. We also got the z variables to have the same coefficient as well. They've both got 30's in front of them, 30z and 30z. Now we're going to take them away here to cancel out the y's, and what I'm actually going to do is I'm going to write this equation below that one. I'm going to do this equation, take away that equation. So I'm going to write this 6x plus 12y's plus 30z beneath the other one, and that's equal to 102. So that's equal to 102, and then I'm going to take them away, so subtract. So 15x's take away 6x's, that's 9x's. 12y's take away 12y's, that's 0. 30z's take away 30z's, that's 0. And then finally 111 take away 102, that's equal to 9. So we've got that 9x equals 9, and then if we divide both of those by 9, we're going to get that x equals 1. So that's fantastic. We've actually found that x is equal to 1. Now that's great. We can actually now substitute that into equation 4. So let's sub x equals 1 into equation 4 and see what we get. So if we substitute 1 in here, what do we get? Well, x, that's going to be 1. Take away 5z, so subtract 5z, equals -9. And then if we want to solve this equation, well, I'm going to add 5z's to both sides. So on the left hand side we'll be left with 1, and on the right hand side we'd have -9 plus 5z's, just adding 5z's to both sides of that equation. Then if we add 9 to both sides of the equation, we're going to get 10 on the left hand side equals 5z's, because obviously -9 plus 9 is equal to 0. And then if we divide both sides of the equation by 5, we're going to get that z is equal to 2. So that's great. We've now got the x equal to 1 and z's equal to 2. Okay, now let's find out what y is. So let's go back up here and let's look at equation 1. So equation 1 is 2x plus 3y plus 5z equals 21. So let's substitute in x equals 1 and z equals 2 into that equation. So let's write down what that equation is here again. So we've got 2x plus 3y plus 5z, and that's equal to 21. And we're going to substitute in, we're going to sub x equals 1 and z equals 2 into equation 1, and let's see what that gives us. So we've got 2x, that's going to be 2 times 1, that's equal to 2, plus 3y, that's still 3y, plus, and then we've got 5z, and that's 5 times 2, and 5 times 2 is equal to 10, and that's equal to 21. Okay, 2 plus 10 is equal to 12, so here we've got 3y plus 12 equals 21. Then if we take away 12 from both sides of that equation, we're going to get that 3y equals 9. And then if we divide both sides by 3, we get that y is equal to 3. So that's great. We've got that x is equal to 1, we've got that y is equal to 3, and z is equal to 2. And that's great. We've now got the values of x, y, and z. And let's just check that. I like to check our answers. So let's substitute those into equation 2 and see what we get and see if that's right. So 3x plus 6y plus 15 equals 51. So let's substitute in x equals 1. So x equals 1. We've got the y equals 3 and that z equals 2. And let's substitute them into equation 2. So let's do that. I'm just going to do that up here. So I'm going to sub x equals 1, y equals 3, and z equals 2 into equation 2. Now whenever you're doing this, try to keep it in quite a tidy format. So here I'm going up here because I want to see this, and I can't see that if I scroll down to the bottom. But if I was doing this on a test paper, I would do this at the very bottom. So here we've got 3x. 3 times 1 is equal to 3, plus 6y, so that's going to be 6 times 3, and that's equal to 18, plus 15z, that's 15 times 2, that's equal to 30. And is that equal to 51? Well, 3 plus 18 is 21, plus 30 is 51, so we get 51 equals 51, and that's it. So we know we're out, so we know that those answers are correct, that x equals 1, y equals 3, and z equals 2, and that's it. Okay, let's look at our next question, question number 3. So question number 3, we've been asked to solve the simultaneous equations 2x plus 4y minus z equals 15, 3x plus 8y plus z equals 44, and x plus 2y plus 2z equals 15. So we've been asked to solve the simultaneous equations. So I'm going to start off by numbering them. I'm going to call that equation 1. I'm going to call the second one equation 2 and the third one equation 3, just to help me remember which one's which whenever I'm dealing with this question and just to sort of show what I'm doing. Okay, so let's cancel some of the variables. So let's start off with z, because here if we look at equation 1 and equation 2, we've got minus z and z. And if we do minus z plus z, that's equal to 0. You know, for instance, if you had minus 10, you add 10, that's equal to 0. So I'm going to add equation 1 and equation 2. I'm going to do equation 1 plus equation 2. So equation 1 is 2x plus 4y minus z equals 15. And equation 2 is 3x plus 8y plus z equals 44. And if we add them together, that'll cancel the z's. So let's just try to add there. Okay, 2x plus 3x is equal to 5x. 4y plus 8y is equal to 12y, and then minus z plus z, that's equal to 0. And then let's add together the 15 and 44, that's equal to 59. Okay, that's fantastic. We've added equation 1 and equation 2 together, and we've got an equation without z, and let's call that equation number 4. Okay, now let's have a look at the equation and see how else we can cancel out the z. So we've used 1 and 2, now let's use 3 and one of the other ones. So we've got 2z. We could double equation 2 and then take them away, because if we do 2z take away 2z, that's equal to 0. So I'm going to double equation 2. So I'm going to do 2 times equation 2. So 2 times equation 2 would be, if we double equation 2, that'll give me 6x plus 16y plus 2z equals 88, just doubling equation 2. And then if we write equation 3 beneath it, so equation 3 is x plus 2y plus 2z equals 15, then we can subtract them from each other. And if we subtract them, that'll cancel out the z's. So let's subtract those two equations from each other. So if 6x take away x would be 5x's, 16y's take away 2y's would be 14y's, 2z take away 2z, that's 0. That's what we wanted to happen. We wanted to cancel out those z's. And that would be equal to, and then if we have 88 take away 15, that's equal to 73. So now we've got another equation without z in it, and I'm going to call that equation 5. Okay, that's fantastic. Now, actually, looking at both of these, they've both got 5 x's, and that's great, because now what we can do is we can do equation 5 take away equation 4 to cancel out the x's. And the reason I'm doing 5 take away 4 is because we'd have 14y's take away 12y's, and that'll leave us with 2y's. You could do equation 4 take away equation 5, then that equals a minus number, but I'm just going to do equation 5 subtract equation 4. So equation 5 subtract equation 4, and we're doing that to cancel out the x's. So I'm just going to write equation 5 to begin with. So I'm just writing it here. There's equation 5, and equation 4 beneath it, 5x plus 12y equals 59. And then let's subtract them and see what we get. So let's do subtract. Okay, 5x's take away 5x's, they cancel out. 14y's take away 12y's, that's equal to 2y's. And then 73 take away 59, that's equal to 14. So that's great. We've now got the 2y's equals 14. If we divide by 2, we'll get the y is equal to 7. So that's great. We'll find out what y is. Y is equal to 7. Okay, now let's substitute that into either equation 4 or equation 5 to find out what x is. I'm going to choose here equation 5 just because I can see it here. So let's sub y equals 7 into equation 5 and see what we get. So 5x, so I'll just say 5x, and then plus, and then we've got 14y, and 14 times 7 is equal to 98, so that's 98, and that equals 73. Then if we take away 98 from both sides, we're going to get that 5x equals negative 25, and then if we divide by 5, we're going to get that x equal to negative 5. So we find out that x is equal to negative 5, just solving that equation. Okay, that's fantastic. We now know that x is equal to negative 5 and y is equal to 7. Now let's go back up and substitute those into either equation 1, 2, or 3. So I'm going to sub x equals negative 5 and y equals 7 into equation 3. Okay, so x, that's going to be negative 5, plus 2y, so 2 times 7, that's going to be 14, so plus 14, plus the 2z is equal to 15. And then let's solve this. Minus 5 plus 14, that's equal to 9. So we get 9 plus 2z equals 15. And then if we take away 9, we're going to get that 2z equals 6. And then if we divide by 2, we're going to get the z equals 3. So that's great. We now know that x is equal to -5, y is equal to 7, and z is equal to 3. So let's check that. And I'm going to sub all of those into equation 2 here to see what we get into equation 2. So let's substitute those into equation 2. So 3x, that's 3 times -5, that's minus 15. Plus 8y, 8 times 7 is 56, so plus 56. Plus z, which is plus 3. And does that equal 44? Well, let's find out. Minus 15 plus 56 is equal to 41 plus 3 is 44. So we get 44 equals 44. So that's right. So that's it. That's correct. So that means our answers are x equals -5, y is equal to 7, and z is equal to 3. And that's it. Okay, let's look at our next question, question number 4. So question number 4, we've been asked to solve the simultaneous equations 10x plus 60y plus 10z equals 25. 5x plus 40y plus 20z equals 40, and 20x plus 20y plus 40z equals 30. Okay, so we want to solve these simultaneous equations. So the first thing I'm going to do is I'm going to number them, equation 1, equation 2, and equation 3. And then let's see which variables we can cancel out. So I'm going to focus on cancelling out the z's here, okay? So you could cancel out the y's or the x's, it's up to you. I'm going to cancel out the z's, okay? So what I'm going to do is I'm going to double equation 1 to begin with. So I'm going to do 2 times equation 1. And 2 times equation 1 would be 20x plus 120y plus 20z, and that equals 50, just doubling everything in equation 1. Then we've got equation 2, which is 5x plus 40y plus 20z, and that equals 40. And here you can see we've got our 20z and our 20z, so let's subtract those two equations. So we're going to do 2 times equation 1, subtract equation 2. So let's see what we get there. So 20x, take away 5x, that'll be 15x. We've then got 120y, take away 40y, that's going to be 80y. And then the 20z, take away 20z, that's 0. And then 50, take away 40, that's equal to 10. So that's great. We've now got an equation without the z term in it, so there's no z variable in this equation. Now we want to get another equation without the z variable, so we've used equation 1 and equation 2. Now what I'm going to do is I'm going to double equation 2 and then use equation 3 to cancel out the z's there, get 40z and 40z. Okay, so let's double equation 2. So 2 times equation 2, let's see what we get. So that would be equal to 10x plus 80y plus 40z, and that's equal to 80, just doubling everything there in equation 2. And then I'm going to write equation 3 beneath it, which is 20x plus 20y plus 40z, and that's equal to 30. Now I could have written it above it and done the subtraction that way. It doesn't really matter, it's just really your own preference. I'm going to do it this way, even though I know that the x term is going to be a negative answer whenever we take them away. I know we're going to get positives for the y terms and the numbers on the end. It doesn't really matter which way you take them away as long as you're cancelling out the z's. So 10x take away 20x, that's equal to minus 10x. I'm just going to write here sub for subtract. 80y take away 20y, that's equal to 60y, so plus 60y. 40z take away 40z, that's 0. And then 80 take away 30, that's equal to 50. So that's great. We've got another equation now without the z term in it, so without the z variable. Okay, so we've now got equation 4 and equation 5. We want to cancel out one of the other variables. So I'm going to cancel out the y's. I'm going to cancel out the y's because here we've got 80y and 60y. I can times this equation, equation 4 by 3 to get 240y. And I can times equation 5 by 4 to get 240y. So I'm going to find 240y. So I'm going to take equation 4 and I'm going to times it by 3. So if I times this by 3, we get 45x plus 240y equals 30. Just times that equation by 3. And then if we times equation 5 by 4, so equation 5 times by 4, so we times this equation by 4, what do we get? So minus 10x times 4 would be equal to minus 40x. We've then got 60y times 4 would be 240y, which is what we wanted. And that equals, when we times 50 by 4, that's equal to 200. So that's great. We've now got two equations with 240y and 240y. Now what we're going to do is we're going to subtract those equations. And I'm going to write sub here. And we've got to be careful here because we're doing 45x's subtract minus 40x's. So 45 minus 40 is equal to 85. So 45x subtract minus 40x would be 85x. 240y take away 240y. is equal to 0. And that would be equal to, and then we've got 30, subtract 200, that's going to be equal to minus 170. Then if we divide both sides by 85, we're going to get that x is equal to, well, minus 170 divided by 85 will be minus 2, because if you double 85, you get 170. So because it's minus 170, it's going to be minus 2. So that means that x is equal to minus 2. So now if we go back up here to equation 4, equation 5, we're going to substitute minus 2 into one of these two equations. And I'm going to substitute into equation 4. So I'm going to go back up here. I'm going to sub x equals negative 2 into equation 4. Because it's just got the x variable and the y variable, and if we know that x equal to negative 2, we can substitute that in and find out what y is. So 15 times x, so 15 times minus 2 would be minus 30, plus 80y equals 10. Then if we add 30 to both sides, because we want to get rid of the minus 30, so we're going to add 30 to both sides, so we're going to get that 80y equals 40, and then if we divide by 80, we're going to get that y is equal to a half, or 0.5. So that's great. We now know that x is equal to negative 2, and y is equal to a half. Now let's substitute those into either equation 1, 2, or 3 and find out what z is. So I'm going to choose equation 1 here. So I'm going to sub x equals negative 2 and y equals a half into equation 1. So 10x, that's 10 times minus 2, that's minus 20. And then plus 60 times a half, well 60 halves is equal to 30, so plus 30, plus 10z equals 25. Then minus 20 plus 30, that's 10. So we get 10 plus 10z equals 25. Then if you take 10 away from both sides, you're going to get that 10z equals 15. And then if you divide by 10, you're going to get that z equals 1.5. So that's great. We now know that x equals negative 2, y is equal to half, and z is equal to 1.5. And let's just check that. Let's check in 3. So let's check. I'm just going to write up here. I'm going to change color of ink here to blue just because we're checking here. So we're going to sub x equals negative 2, y equals a half, and z equals 1.5 into equation. And we've used equation 1, so I'm going to choose equation 3 here. So 20x, that's 20 times minus 2, that's minus 40. And then we've got plus 20 times y, that's 20 times a half, that's equal to 10. And then plus 40 times 1.5, that's equal to 60. And is that equal to 30? Let's find out. Minus 40 plus 10 is equal to minus 30, plus 60 is equal to 30. So you get 30 equals 30. And that's it, so that's right. So that means that there are answers. And let's write that down. The x equals negative 2, the y equals a half, and that z equals 1.5. Actually, you could write the y as 0.5 if you wanted to, rather than a half. It's up to you. But that's it. I'm just going to actually change it to 0.5 there, just to be consistent in terms of our decimals. And that's it. Okay, let's have a look at our next question, question number 5. So question number 5, we've been asked to solve the simultaneous equations x plus y plus z equals 1, 4x minus 3y plus 4z equals 32, and x minus 10y minus 2z equals 27. Okay, so we want to solve these simultaneous equations. So the first thing I'm going to do is I'm going to number them. So I'm going to call that first one equation 1, the second one equation 2, and this third one equation 3. Okay, let's see how we can eliminate one of the variables. So if we look at equation 1 and equation 3, they both have an x in it. So that means that if we subtract those two equations from each other, equation 1 and equation 3, the x's will cancel because x take away x is equal to 0. Now let's see how we're going to do it. Are we going to do equation 1 subtract equation 3 or equation 3 subtract equation 1? Now I'm thinking we're going to do equation 1, so we're going to do equation 1 subtract equation 3. And the reason I'm doing that is because if we write equation 1, which is x plus y plus z equals 1, and then we write equation 3 beneath it, which is x minus 10y minus 2z equals 27. You can see that if we take these away, well, the x take away the x will be 0, but then we've got y subtract negative 10y, so that means we're going to be adding the 10y's on, so that means it'll be 11y's, whereas if we done it the other way around and we done equation 3 subtract equation 1, we would have minus 10y's take away y, which would be minus 11y's. So I'm going to do it this way here. It doesn't actually matter which way around you do it, but I'm just going to do it this way. So we're going to do equation 1 subtract equation 3, and I'm going to write here sub, just so I know that I'm subtracting here. So x take away x is 0. Y subtract negative 10y. Well, y minus 10y would be 11y's because we're going to be adding them on. Then we've got z subtract negative 2z's. Well, z take away minus 2z's would be z plus 2z's, which would be 3z's. And then finally, we've got 1 subtract 27. And 1 subtract 27 is negative 26, or minus 26. So that's fantastic. And I'm going to call that equation 4, because that is an equation with just two variables. We've got our 11y plus 3z. So we've got our y's and our z's. And the x's have been eliminated. So that's going to be quite useful for us. Okay, so we've eliminated the x's using equation 1 and equation 3. So let's have a look now and see how we can eliminate x if we use equation 2. So it's got 4x. So what we're going to do is we're going to either want to multiply equation 1 by 4 or equation 3 by 4 to get 4x as well. So I'm going to times equation 1 by 4. So I'm going to do 4 times equation 1. So let's write that down. 4 multiplied by equation 1. That would give us, multiplying everything here by 4 would be 4x plus 4y plus 4z. And that equals 4. Just multiplying everything there by 4. Okay, so that's fantastic. We've now multiplied everything in equation 1 by 4, and I'm just going to call that equation 5 for the minute. Okay, so we want to eliminate x, so we've got here 4x's, and in equation 2 we had 4x's. So I'm going to do equation 5, take away equation 2, because that will eliminate those 4x's. So let's write that down. 5 subtract equation 5, subtract equation 2. So equation 5 is 4x plus 4y plus 4z equals 4. And equation 2 is, if I just write that down beneath it, 4x minus 3y plus 4z equals 32. Okay, so that's fantastic. Okay, so we're now going to take away these two equations, and what's fantastic here is that I've actually noticed that we're going to eliminate x, but we're also going to eliminate z. So let's do that. 4x's, take away 4x's, well that's 0. We've then got 4y's subtract, I'm just going to write here, subtract minus 3y. Well, 4y minus 3y would be 7y. Then we've got 4z, take away 4z, that's 0. And then we've got 4 subtract 32. And 4 subtract 32 is equal to negative 28. And then if we divide both sides here by 7, we're going to get that y is equal to negative 4. So we find out what y is. Y is equal to negative 4. So that's fantastic. So here, instead of eliminating just the x's, we're able to eliminate the x's and the z's, which is fantastic. So we've now got that y is equal to negative 4. I'm just going to write it in here, and we will check it later, but I'm just going to write it there for the minute, that y is equal to negative 4. Okay, now we can actually substitute that into equation 4. So I'm going to sub y equals negative 4 into equation 4, the one we found earlier with just the y's and the z's. So 11y, well 11y, so we've got 11y plus 3z equals negative 26, and we're going to substitute in negative 4 here into here. So we've got 11 times negative 4, that's negative 44, plus 3z equals negative 26. And if we add 44 to both sides, we're going to get 3z on the left hand side, and on the right hand side we're going to be left with 18, because negative 26 plus 44 is equal to 18. And then if we divide both sides by 3, we get z equal to 6. So that's great, we've now got that z equal to 6. I'm actually just going to move that working out there because it's actually moving into the answer box there for x. So we're just going to move this down here. Okay, so we've found y and we've found z. We will check these later. Now let's find what x is. And I'm going to substitute these two values, the y is equal to negative 4 and the z is equal to 6, into equation 1, because equation 1 was quite nice. So if we substitute in y equals negative 4 and z equals 6, if we substitute those two into equation 1, let's see what we get. So x, that's going to be what we're trying to find, plus y, which is negative 4, plus z, which is 6, equals 1. And then if we work this out, well, we've got x, and then we've got plus negative 4, that means just minus 4, plus 6, well, negative 4 plus 6 is 2, so plus 2 equals 1. And then if we take 2 away from both sides here, we're going to get that x is equal to negative 1. So that's fantastic, we find that x is equal to negative 1. So let's write that in as well, so x is equal to negative 1. And let's just check our answers. I like to check our answers and make sure we've got them right. So I'm going to substitute these values are sub x equals negative 1, y equals negative 4, and z equals 6 into, and let's choose one of these equations. I'm going to choose equation 2, and let's see what we get. Well, 4x, 4 times negative 1 is negative 4, and then subtract, and then we've got subtract, and then 3 times negative 4, well, 3 times negative 4 is negative 12, so negative 12, and then we've got plus, and 4 times z, so 4 times 6 is 24, and then is that equal to 32? Well, let's just check and see. Well, negative 4 minus 12, so the minus, that means plus, so minus 4 plus 12 is 8, plus 24 is 32, so we get the 32 equals 32, so we're right, and that's it. So we know we've got that right answer, and that's it. So x equals to negative 1, y is equal to negative 4, and z is equal to 6. Okay, let's look at our next question, question number 6. Okay, let's have a look at our next question, question number 6. So question number 6, we've been asked to solve the simultaneous equation 6x plus 8y minus 2z equals 750, 18x minus 2y plus 4z equals 1100, and 4x minus 4y plus 2z equals 100. Okay, so let's label the equations, equation 1, equation 2, and equation 3. Okay, so let's look at cancelling out some of the variables. I'm actually going to look at the z's because here we've got minus 2z and 2z, so we can actually add these two equations straight away, equation 1 and equation 3. So we can do equation 1 plus equation 3, and we can cancel out the z's. Now, actually looking at the answers on the website, I've noticed that I've cancelled out the y's, but it doesn't actually matter which variables you cancel out. You're going to get the same answers at the end, but here I'm going to cancel out the z's here. So if we add equation 1 and equation 3, you can see minus 2z plus 2z would be 0. So let's write equation 1, which is 6x plus 8y minus 2z, and that's equal to 750. And then beneath that, let's write our 4x minus 4y plus 2z equals 100. And we're going to add those two equations, and let's see what we get. So 6x's plus 4x's, that's 10x's. Then we've got 8y's plus minus 4y's. When you add negative 4y's, it's going to go down 4y, so it's going to be plus 4y. And then minus 2z plus 2z will be equal to 0. And that's equal to 850. So here we've got an equation where we've eliminated the z's. And I'm going to call that equation 4. Okay, now let's find another equation where we've eliminated the z's. And I'm looking at equation 2 and equation 3. If I double equation 3, I'm going to get 4z, and then I can take them away. So let's double equation 3, and then take that away from equation 2. So I'm going to do equation 2, so equation 2, subtract 2 times equation 3. So let's write equation 2 to begin with, which is 18x minus 2y plus 4z equals 1100. So that's equation 2. And I'm going to double equation 3 and then take it away from equation 1. So let's just double equation 3 to begin with. So that'll be 8x minus 8y plus 4z equals 200. So that's doubling equation 3. And now we want to take these away to cancel out the 4z's. So let's subtract them from each other and see what we get. So let's do subtract. So 18x take away 8x, that's going to be 10x. Then we've got minus 2y minus 8y. Well, if you're subtracting a negative, you're going to add it back on. So if you've got minus 2y and you add 8y, you're going to go back up to 6y, so plus 6y. 4z take away 4z is 0. And 1100 take away 200 would be 900. So that's fantastic. We've now got another equation where we don't have any z's in it. So we've eliminated the z's. And let's call that equation 5. Now this is great. If we look at equation 4 and equation 5, they both have 10x. That's fantastic. So I'm going to do equation 5, take away equation 4, because equation 5 has 6y's and equation 4 has 4y's. And if we take them away, then the number of y's will be positive. So let's do that. So let's do equation 5, subtract equation 4, and let's see what we get. So equation 5 is 10x plus 6y equals 900. And equation 4 is 10x plus 4y equals 850. And then if we take them away from each other, let's see what we get. So 10x's take away 10x's, so they cancel out. 6y's take away 4y's, that's 2y's. 900 take away 850 is equal to 50. And that's it, so 2y's equals 50. And then if we divide by 2, we get y's equal to 25. So that's great, y's equal to 25. Okay, now let's substitute that back into one of the other equations. So I'm going to substitute that back into equation 5, and let's see what we get. So equation 5, if we sub y equals 25 into 5. So 10x, so that's 10x, what we're trying to find, plus 6 times y. So 6 25s is 150 equals 900. And then if we take away 150 from both sides, we get 10x equals 750. And then if we divide by 10, we get that x is equal to 75. So x is equal to 75. So we've now found out what x is, and we know what y is. So now let's find out what z is. So let's substitute these back into one of our original equations. And I'm thinking equation 3 might be a good one to choose here. So sub x equals 75 and y equals 25 into equation 3. So equation 3, 4x, so 4 times 75 would be 300. Subtract 4y, so 4 25s is 100, so take away 100, plus 2z equals 100. So 300 take away 100 is equal to 200, so we've got 200 plus 2z equals 100. And then if we take away 200 from both sides, we get that 2z equals minus 100. And if we divide by 2, we get the z is equal to negative 50. So that means that z is equal to negative 50 there. And that's it. And let's just check our answer. I like to check our answer, so let's go back up here and let's substitute them all into equation 1. So I'm just going to substitute these into equation 1 and see what we get. So 6x, so 6 times 75 would be equal to 450, so 450, plus 8 times y, so 8 25s is 200. Take away 2 times z, so 2 times minus 50 is minus 100, so we're going to take away minus 100, and let's see what we get. So 450 plus 200 is 650, minus 100 means add another 100 on, which is 750. So we get 750 equals 750, so we know we're right. And that's our answer, that x equals 75, y is equal to 25, and z is equal to negative 50. And that's it. Okay, let's have a look at question number 7. So question number 7, we've been asked to solve the simultaneous equation 7x plus 5y plus 4z equals 23, 21x subtract 10y plus 6z equals negative 4, and 7x plus 15y subtract 2z equals negative 15. Okay, so let's number them. We've got equation 1, equation 2, and equation 3. And in terms of the variables that we want to cancel out here, we could cancel out the x's quite nicely. We could multiply the top equation by 3 to get 21x, and we've got 21x here, and then take away the equations. Likewise, we could multiply equation 3 by 3 as well, and we would get 21x. So I think with cancelling out the x's would be quite a good choice here. In terms of cancelling out the y's, because we've got 5y minus 10y and 15y, that'd be quite nice as well. And also the z's are quite nice to cancel out because we've got 4z, 6z, and minus 2z. I'm going to do this question by cancelling out the x's just because I think that'd be a bit easier to multiply equation 1 by 3 and equation 3 by 3 and then just cancelling them out using the 21x. Okay, so let's do 3 times equation 1 and see what we get. So 3 times equation 1 would be 21x plus 15y plus 12z, and that equals 69. Okay, and then going to write equation 2 beneath it, so 21x subtract 10y plus 6z, and that's equal to negative 4. And we want to cancel out the x's, so let's subtract these two equations from each other. So let's subtract them from each other and see what we get. So let's write subtract there. Okay, 21x take away 21x, that's 0, so they cancel out. We've then got 15y subtract minus 10y. So we're going to do 15y minus 10y. So we're going to add on the 10y's. So that's going to be 25y. Then we've got 12z take away 6z. That's going to be plus 6z. And then finally, we've got 69 subtract minus 4. So 69 minus 4 would be 73. So that's fantastic. And I'm just going to call that equation 4 because that's an equation without the variable x in it. And we might use it later on. Okay, so we've eliminated x using equation 1 and equation 2. Now let's use equation 3 and equation 2. So I'm going to do 3 times equation 3, so 3 times equation 3 and see what we get. So that would be if we times equation 3 by 3, we would get 21x plus 45y minus 6z equals negative 45. So that's 3 times equation 3. And then let's write equation 2 beneath it. So 21x minus 10y plus 6z equals negative 4. And we're going to subtract those two equations from each other and cancel out the x's. So 21x take away 21x, they cancel out. 45y subtract minus 10y would be 55y. Minus 6z take away 6z, that would be minus 12z. And then finally, minus 45 minus 4. So it means we're going to go back up 4, so that would be minus 41. Okay, so that's fantastic. We've now got two equations without x in it. And I'm going to call that equation 5. So that's going to be equation 5. Okay, so that's equation 5. Now, if we have a look at equations 4 and equation 5, we've got one equation with 6z and another equation with minus 12z. I'm going to double equation 4. So let's do 2 times equation 4 and see what we get. So double equation 4. So that'll be 50y plus 12z equals 146. So here we've just doubled equation 4. And let's write equation 5 beneath it. So 55y minus 12z equals negative 41. So we've got equation 4 and we've doubled it, and we've got equation 5 there. Now if we add them together, that's going to cancel out the z's. So let's add them together and see what we get. 50y plus 55y would be 105y. And then we've got 12z plus minus 12z, that's going to be 0. And then we've got 146 plus negative 41. So that's going to bring us back down 41, so that's going to be 105. So that's fantastic. That means that y would be equal to 1. So that means we've found that y is equal to 1. So now let's find our x and z. So let's substitute this y is equal to 1 into equation 4 here. So we've got, if we sub, let's write that down, sub y equals 1 into equation 4. Now, I've moved around quite a bit here in terms of my method. I've done some method here and then gone up here and then down here. Now, whenever you're doing questions like this, it's important to be quite organized whenever you're laying it out so the examiner can see what you've done. I've sort of set it out this way just because I'm trying to keep it all visible on the computer screen. If I had an A4 piece of paper, obviously in portrait style, I'll probably just work down the page and that'll be fine as well. Okay, so here we've got substitute y is equal to 1 into 4. So equation 4 here, we're going to substitute y is equal to 1 here. So it'll be 25 times 1, that's 25, plus 6z is equal to 73. And if we take 25 away from both sides, we're going to get 6z equals, and if we take 25 away from 73, we get 48. And then if we divide by 6, we're going to get that z's equal to 8. So z's equal to 8. So that's great. We've now got that y is equal to 1 and z's equal to 8. Okay, now let's find x. So let's substitute these into equation. Let's substitute them into equation 1. So equation 1, I'm just going to write it down here. Okay, so there's equation 1, and we're going to substitute in, y equals 1 and z equals 8 into equation 1. So let's substitute these into this equation. So we've got 7x, that's 7x, plus 5y, so 5 times 1 is 5, plus 4z, 4 times 8 is equal to 32, and that equals 23. 5 plus 32 is equal to 37, so we've got 7x plus 37 equals 23. If we take away 37 from both sides, we get 7x equals negative 14. And if we divide by 7, we get x equal to negative 2. So that means x equal to negative 2. And that's it. So x equal to negative 2, y is equal to 1, and z is equal to 8. And let's just check that. So we go back up, we can check in equation 2. So if we check here, we've got x is equal to, let's just remind ourselves, x equal to negative 2. So it's going to be 21 times negative 2 is negative 42. Take away 10 times y, so it's going to be take away 10. And then we've got plus 6 times z, z's equal to 8. Yep, so 6 times 8 is 48, so plus 48. So will that be equal to negative 4? Negative 42, take away 10 is negative 52, plus 48 is equal to negative 4. So you get negative 4 equals negative 4, so it's right. And that's it. So we know we're correct. And that's it. Okay, let's look at our next question. So question number 8, we've been asked to solve the simultaneous equations y subtract x plus 2z equals 2.1, 3x minus 2z minus y plus 2.5 equals 0, and 8z plus 10y plus 5x equals 4.5. So in terms of solving these simultaneous equations, you'll notice here that they've sort of been jumbled up. So rather than being an x, a y, a z, and then equals a number, here we've got a y, then subtract x plus z equals a number. Here we've got actually the plus 2.5 and then equals 0. And here we've got the z, y, and then x. What I'm actually going to do is I'm actually just going to rearrange these. So in terms of the first one, I'm going to put the minus x at the front, and then the plus y, and then the plus 2z. And then that equals 2.1. So just rearrange that, putting the minus x at the front, and then we've got the plus y. And I'm going to number that equation 1. Then in terms of the next equation, we've got the 3x, which is great. We've then got, I'm going to put the minus y next, and then the minus 2z. And then here, instead of writing plus 2.5, I'm going to subtract 2.5 from both sides. That'll give us minus 2.5 on the right-hand side. And that's going to be equation number 2. And then in terms of equation number 3, I'm just going to rearrange these. So it's going to be 5x, and then plus 10y, and then plus 8z equals, and then we've got our 4.5. And that's equation number 3. Okay, so we've just rearranged the orders there. Okay, so now let's solve these simultaneous equations. So here, if we have a look at the z's, we've got 2z and minus 2z. So if we add equation 1 and equation 2, that'll cancel out the z's. So let's do that. So let's do equation 1 plus equation 2. It's actually going to cancel out the y's as well. So we've got minus x plus y plus 2z. And that's equal to 2.1. And then we've got 3x minus y minus 2z, and that's equal to minus 2.5. And we're going to add those two equations together. So minus x plus 3x would be 2x. Then y plus minus y, well, minus y plus y is equal to 0. Minus 2z plus 2z is equal to 0 as well. And then we've got minus 2.5 plus 2.1, that's going to be equal to minus 0.4. And then if we divide both sides by 2, we get that x is equal to minus 0.2, or minus a fifth. Okay, so that's fantastic. We'll find out what x is. Now, we haven't actually got an equation that we can substitute that into to find out y or z yet, because we only have these 3 original equations with x, y's, and z's in them, and we've also just this equation with x's. So what I'm now going to do is I'm now going to look at equation number, well, we've got equation 3, which is 8z. I'm going to multiply equation 2 by 4. That'll give us minus 8z. And then we can do our minus 8z plus 8z. Z. So if we do 4 times equation 2 and then add equation 3. So let's write down what 4 times equation 2 is. So 4 times equation 2. And 4 times equation 2 would be, well, we'd have 12x minus 4y minus 8z is equal to, and then minus 2.5 times 4 would be minus 10. So that's 4 times equation 2. And then we've got equation 3, which is 5x plus 10y plus 8z, and that's equal to 4.5. So that's great. Now we can add these two equations together to cancel out those z's. So let's do that. So let's add those two equations together. So let's write there add. And actually we're just going to go back up here and write add as well, because we added those two equations to cancel the z's. So 12x plus 5x, that's equal to 17x. Next, minus 4y plus 10y, that's equal to 6y, so plus 6y. And then minus 8z plus 8z, they cancel out, that's equal to 0. And then we've got minus 10 plus 4.5, that's going to be minus 5.5. Now let's substitute in our value for x equal to minus 0.2. So we substitute that in here. We're going to sub, and let's actually number that equation 4. So let's substitute x equals minus 0.2 into equation 4. So into equation 4. And see what we get. So 17 times x, so that's going to be 17 times minus 0.2. That's equal to minus 3.4, and that's a calculator question. And then we've got plus 6y equals minus 5.5. So we want to find out what y is, so let's add 3.4 to both sides. So on the left-hand side, we'll get 6y. We had minus 5.5, we're adding 3.4, and that's equal to minus 2.1. And then if we divide both sides by 6, we're going to get that. If we do minus 2.1 divided by 6, that's equal to minus 0.35. So that means that we've got so far that x is equal to minus 0.2, the y is equal to minus 0.35, and we want to find out what z is. So let's substitute these two back into one of the equations that we've got at the beginning. And I'm going to choose equation number 3 here, so equation number 3. So we're going to sub x equals minus 0.2 and y equals minus 0.35 into equation 3 and see what we get. So 5x, 5 times minus 0.2 would be minus 1. And then we've got 10 times y, that's 10 times minus 0.35, so it's going to be minus 3.5. And then we've got plus 8z, and that's equal to 4.5. Okay, now let's simplify this. So we've got minus 1 subtract 3.5, so it's going to be minus 4.5, and then plus 8z equals 4.5. And then if we add 4.5 to both sides, we get on the left-hand side 8z, and that's equal to 9. And then if we divide by 8, if we divide both sides here by 8, we're going to get that z is equal to, and 9 divided by 8 is equal to 1.125. So that's great. We've got that z is equal to 1.125. And that's it. So we've got our values for x, y, and z. Okay, so let's check these. So let's substitute them back into equation number 1. So let's substitute in x equal to minus 0.2. So that's going to be minus that. So it's going to be 0.2. And then plus y. Well, so y was equal to minus 0.35. So that's going to be minus 0.35. And then plus 2 times z. So multiply z by 2 is equal to 2.25. And then if we work that out, does it equal 2.1? So let's see. So 0.2 subtract 0.35 plus 2.25 is equal to 2.1. So we get 2.1 equals 2.1. So that's it. We know we're right. And that's it. We've solved the simultaneous equations. So x is equal to minus 0.2, y is equal to minus 3.5, and z is equal to 1.125. And that's it. Okay, let's have a look at our next question, question number 9. So question number 9 says, Roshan sells vehicles for a company, and she receives X pounds commission for each car sold, Y pounds commission for each motorcycle sold, and Z pounds commission for each van sold. And during January, Roshan sold 12 cars, 16 motorcycles, and 3 vans, and she receives a total commission of £1,590. And we've been asked to show that X, Y, and Z satisfy this equation. So we've got this equation here. 4x plus 2y plus z equals 530. That doesn't actually look like what we've been given. We had 12 cars and 6 motorcycles and 3 vans, and it was 1,590, but this is only 530. But what we're going to do is we're going to form an equation using the information we've been given, and then we're going to simplify it, and hopefully we're going to get to this. Okay, so for each car she sells, she gets X pounds. So if she sells 12 cars, we're going to do 12 times x. And 12 times x would be 12x, because we'd multiply the commission for one car by 12 to find out how much commission Roshan would receive for 12 cars. And then she sells 6 motorcycles, so then we'd add on 6 multiplied by y, because for each motorcycle she sells, she gets y pounds commission, so 6 times y is 6y. And then we'd add on, well, she sells 3 vans, so that's 3 times z, so it's going to be 3z. And that's equal to £1,590. Now what we're trying to show isn't quite what we've found there. We've got 12x plus 6y plus 3z equals 1,590. Now if we divide everything here by 3, because 12x, 6y and 3z are all divisible by 3, and also 1,590 is divisible by 3, let's see what we get. So let's divide everything by 3 and see what we get. So if we divide the left hand side of the equation by 3 and the right hand side of the equation by 3, so on the left hand side if we divide everything by 3, we get that's equal to 4x plus 2y plus z. So that's what we're trying to find, that's great. And if we do 1,590 divided by 3, that's equal to 530. So that's it, that's what we've been asked to show, so we've done it. Then if we carry on, we're told during February, Roshan sold 10 cars, 5 motorcycles and 5 vans, and she received a total commission of £1,600. And we've been asked to show that x, y and z satisfy that equation. Okay, so this equation here. So what we're going to do is, well, we know she sold 10 cars, that's going to be 10x, 10 times the commission for one car, plus 5 times y, because each motorcycle she receives y pounds, so it'd be 5 times y, and then plus 5 times z, because for each van she receives z pounds commission and she sold 5 of them. And we know that total commission was equal to £1,600. Now everything there is divisible by 5, so if we divide everything by 5 on the left hand side and everything by 5 on the right hand side, we're going to get 10x divided by 5 is 2x, 5y divided by 5 is y, and 5z divided by 5 is equal to z, and that's equal to 320. And that's great, that's what we were asked to show, so we've shown that as well. Okay, let's look at our next bit. Our next bit then says, during March, Roshan sold 18 cars, 4 motorcycles and 6 vans, and she received a total of £2,350 commission. And we've been asked to show this equation here. So 18 cars, that's going to be 18x plus 4y plus 6z. Because it's going to be 18 times x, 4 times y, and 6 times z, and that'll be our total commission, which is £2,350. Now we can divide everything by 2 there. If we divide everything on the left hand side of the equation by 2 and on the right hand side of the equation by 2, we get 9x plus 2y plus 3z is equal to £1,175. And that's it, we've shown that equation as well. So that's fantastic. So we've now found the 3 equations that we've been asked to find. I'm guessing our next page, if we turn over, will be to solve those simultaneous equations. So let's see if that's the case. Yeah, so we've been asked to solve the simultaneous equations, those 3 equations we've shown already. We've been asked to solve them to find the commission Roshan receives for selling each type of vehicles. So if we find out what x is, that'll be how much she receives for each car she sells. Then if we find out what y is, that'll tell us how much commission she receives for selling each motorcycle. And if we find out what z is, that'll be how much commission that Roshan receives for selling each van. So let's do that. So let's number our equations. I'm going to number them 1, 2 and 3. Okay, so we've numbered them 1, 2 and 3. Now we need to choose what variables we're going to eliminate. I'm actually going to eliminate the y's, because if we double equation 2, if we do 2 times equation 2, so I'm just going to write it here, 2 times equation 2, that's equal to, if we double it all, we get that's equal to 4x plus 2y plus 2z is equal to 640, and that's equation number 4. Okay, and we're going to number that equation number 4. So we've now got these equations, equation 1, equation 2 and equation 3, and I've doubled everything in equation 2 to give us equation 4. And if you have a look here, all of them now got 2 y's, so that means we can eliminate the y's quite easily. So I'm going to start off by doing equation 3 subtract equation 1. So I'm going to do equation 3 subtract equation 1 to begin with. So that would be 9x plus 2y plus 3z equals £1,175. That's equation 3. Subtract equation 1, which is 4x plus 2y plus z, and that's equal to £530. And if we take them away from each other, that'll then eliminate the y's. So let's do that. So let's subtract. 9x take away 4x, that's 5x. 2y take away 2y, that's 0. And then we've got 3z take away z, that's going to be 2z, so plus 2z. And then that's equal to, if we do 1,175 subtract 530, that's equal to £645. So that's great. So we've got this equation without any y's, and I'm going to call that equation number 5. Okay, so we've eliminated y from using equations 3 and 1. Now we want to use equation 4 here because that'll be, we've used 1 and 3. We want to use equation 2, and equation 4 is what we get when we double equation 2. So let's use equation 4, and I'm going to do equation 3 subtract equation 4. So let's write that down. Equation 3 subtract equation 4. So equation 3 is 9x plus 2y plus 3z equals £1,175. And equation 4 was up here. It's 4x plus 2y plus 2z equals £640. Okay, so we've got those equations. Now what we're going to do is we're going to take them away to eliminate y. So let's do that. So 9x take away 4x, that's 5x. 2y take away 2y, that's 0. They're eliminated, that's what we wanted. And then we've got 3z take away 2z, that's equal to z. And if we take them away from each other, the 1,175 take away 640, that's equal to 535. So that's great. We've now got equation 5 and equation 6 there. And equation 5 and equation 6 both have 5x's. So if we take them away, we'll find out what z is. So let's do that. So let's do equation 5 subtract equation 6. So equation 5 is 5x plus 2z, and that's equal to 640. And equation 6 is 5x plus z, and that's equal to 535. And if we take them away from each other, that'll eliminate the x's. So 5x's take away 5x's, they cancel out. 2z's take away z, that's z. And 645 take away 535, that's equal to 110. So that means that z is equal to 110. So that means that the amount of commission that Roshan receives for selling a van is £110. Okay, now we find out what z is. Now let's substitute that back into equation 6 to find out what x is. So 5x, so let's write that down, sub z equals 110 into equation 6. So 5x is 5x plus 110 is equal to 535. If we take away 110 from both sides here, we get the 5x equals 425. And then if we divide both sides of the equation by 5, so if we do 425 divided by 5, that's equal to £85. So that means that Roshan receives £85 for each car sold. And then finally, the motorcycles. So we want to find out what y is. So let's substitute in 85, 110 back in 2. And I'm going to choose equation number 2 here. It's probably the easiest one here. So if we substitute those into equation 2, and I'm just going to write equation 2 down here. So if we go on down, equation 2 is 2x plus y plus z equals 320. And we're going to sub x equals 85 and z equals 110 into that equation. So 2x, that's going to be double that is 170, plus y plus 110 is equal to 320. 170 plus 110, that's 280, plus y is equal to 320. And if you take away the 280 from both sides, you get that y is equal to 40. So that means that Roshan receives £40 for each motorcycle sold. So that's great. And let's just go up and check our answers. So is x equal to 85? So we'll find that x is equal to 85, that y is equal to 40, and that z is equal to 110. So let's just check that in equation number 1. I'm just going to change the color of ink here. So 4 times x, so 4 times 85 is 340. 2 times y, so that's going to be 80, and then plus 110. And when we add these together, do we get 530? Let's see. 340 plus 80 plus 110 is equal to 530. So that's great. So we get 530 equals 530, so we know we're right. And that's fantastic, knowing we're right. And that's it. Okay, let's have a look at our next question. Okay, let's look at our next question, question number 10. So question number 10 says a football team sells 3 types of season ticket: an adult season ticket, a child season ticket, and a pensioner season ticket. And this year the McManus family bought 4 adult season tickets at X pound each, 6 child season tickets at Y pounds each, and 2 pensioner season tickets at Z pounds each. And the total cost of the tickets was £5,650. We've been asked to show that X, Y, and Z satisfy the equation 2x plus 3y plus z equals 2,825. Okay, so let's form an equation with the information we've been told. So they bought 4 adult season tickets at X pound each. So if we wanted to work out the total cost of those 4 season tickets, we would do 4 times x, 4 times the cost of one of them, so 4x. And then we've got 6 child season tickets at Y pound each. Well, if we do 6 times y, that'll be the cost of the child season tickets. So if we add that to the 4x, that'll be the cost of the adult and the child season tickets. And then finally, there's 2 pensioner season tickets at £Z each. So we're then going to do plus 2Z. So that would be the total cost of the season tickets for the McManus family. And that's equal to, we're told in the question, that's equal to £5,650. So that's fantastic. Now, if we have a look at what we're trying to show, what we're trying to show isn't actually this, but it's half of it. If we halve everything in this equation, if we divide it all by 2, if we divide everything on the left-hand side by 2, and everything on the right-hand side by 2, on the left-hand side, we'd get 2x plus 3y plus z, which is what we're trying to show there. And that's equal to £2,825. And that's it. So 2x plus 3y plus z equals 2,825. And that's what we're asked to show. Okay, and then if we carry on, we're then told the cost of 2 adult season tickets is £100 more than the total cost of 2 child season tickets and 2 pensioner season tickets. Okay, so what that means is that if we take the cost of an adult season ticket, which is X, and we times it by 2, that's the cost of 2 adult season tickets, that's £100 more than the total cost of 2 child season tickets, that's going to be 2Y, and 2 pensioner season tickets, that's 2Z. So let's just go back to this and just make sure we understand what's happening. So the cost of the 2 adult season tickets is £100 more than the total cost of these 2. So in other words, if we take the 2 adult season tickets and take away the cost of the 2 child season tickets and the cost of the 2 pensioner season tickets, the answer would be £100. So it's going to be 2x minus 2y minus 2z equals 100. That's the cost of 2 adult season tickets, take away the cost of 2 child season tickets, take away the cost of 2 pensioner season tickets is equal to £100. Now you could write it in a slightly different way. You could have written it this way here, that you'd have the cost of the 2 adult season tickets and then take away the combined cost of the 2 child season tickets and the 2 pensioner season tickets. So you'd add together their cost and then take it away from the 2x, and that's equal to 100. And just remember here, whenever you do expand these brackets, this is a minus 1, so you can do minus 1 times 2y, which is minus 2y, and then minus 1 times 2z would be minus 2z. So you get to this stage anyway. But this is just saying the cost of 2 adult season tickets, take away the cost of 2 child season tickets, take away the cost of 2 pensioner season tickets equals £100. And then if we divide everything by 2, if we divide by 2 and divide by 2, we're going to get that x minus y minus z equals 50. And that's it. So that's what we're asked to show. Okay, and then if we go on down, and then we're told that last year all season tickets cost £25 less than the current prices. And we're told last year the Wilcox family bought 4 adult season tickets, 8 child season tickets, and 4 pensioner season tickets, and the total cost was £6,600. And we've been asked to show that x, y, and z satisfy the equation x plus 2y plus z equals 1,750. Okay, so last year the season tickets were £25 less than the current price. So for the adult season ticket this year, the cost is X pounds. So that's the cost of the adult season ticket this year. But last year was £25 less. So that means that it would be X minus 25. It would be X minus 25. That's the cost of the adult season ticket last year. Whatever the cost is this year, minus £25. But the Wilcox family bought 4 of them. So we're then going to times that by 4. So that'll be the cost of the adult season tickets last year for the Wilcox family. The child season tickets, this year it's Y pound. But last year it was £25 less, so minus 25. And they bought 8 of them, so we're then going to times that by 8. And finally, the 4 pensioner season tickets, well, this year they cost Z pound, but last year they're £25 less, that's minus 25. And the Wilcox family bought 4 of them, so it's going to be 4 times that. So this would be, if we add these together, this would be the total cost of the season tickets. It'll be 4 bracket X minus 25 plus 8 bracket Y minus 25 plus, and then 4 bracket Z minus 25. So that's the cost of the season tickets last year for the Wilcox family, and that was equal to £6,600. And then if we expand our brackets and simplify, we should hopefully get to this. So 4 times x is 4x, 4 times minus 25 is minus 100, then plus 8 times y is 8y, and then 8 times minus 25 would be minus 200, then 4 times z, that's going to be 4z, and then 4 times minus 25, that's minus 100, and that's equal to 6,600. And then if we simplify this, let's look at these numbers. Minus 100, minus 200, that's minus 300. Minus another 100, that's minus 400. So we've got 4x plus 8y plus 4z minus 400 equals 6,600. Then if we add 400 to both sides, if we add 400 to the left-hand side and add 400 to the right-hand side, we'd be left with 4x plus 8y plus 4z equals 7,000. And then if we divide everything by 4, if we divide by 4 and divide by 4, we're going to get x plus 2y plus z equals 1,750. And that's it. That's what we're asked to show. So now if we carry on, we're going to probably be asked to solve those three simultaneous equations that we've shown there. So let's have a look at that. Yep, we've been asked to solve the simultaneous equations 2x plus 3y plus z equals 2,825, x minus y minus z equals 50, and x plus 2y plus z equals 1,750. Okay, now in terms of the variables I'm going to cancel, let's number them. We've got equation 1, equation 2, and equation 3. And I'm going to cancel out the z's here because with a z, a minus z, and a z, they're going to be quite nice to cancel out. So I'm going to do equation 1 plus equation 2 to cancel out the z's. So let's write that down. So equation 1 plus equation 2, and let's see what we get. So equation 1 is 2x plus 3y plus z equals 2,825, and equation 2 is x minus y minus z equals 50. And if we add the two equations together, let's write add there, let's see what we get. 2x plus x is 3x. 3y plus minus y, well, minus y plus 3y would be 2y, so plus 2y. And then minus z plus z, that's equal to 0. And then if we add together 2,825 and 50, we get 2,875. So that's what we get when we add equation 1 and equation 2. And you'll notice there's no z's there. And let's call that equation 4. Now I'm going to add equation 2 and equation 3 to cancel out the z's as well. So I'm going to do equation 2 plus equation 3. So equation 2 is x minus y minus z equals 50. And equation 3 is x plus 2y plus z equals 1,750. And let's add them together and see what we get. So x plus x, and let's write there add just to make sure we know we're adding them. X plus x is 2x. Minus y plus 2y, that's equal to y, so plus y. And then minus z plus z, that's equal to 0, so they're going to cancel out. And that's equal to 1,800. That's great. And let's call that equation 5. So that's equation 5. Okay, so that's great. We've now got two equations, equation 4 and equation 5, that do not have z's in them. So now let's have a look at them. We've got y and 2y. So what I'm going to do is I'm going to double equation 5. So I'm going to do 2 times equation 5. And 2 times equation 5, if we double that equation, would be 4x plus 2y equals 3,600. And we've got equation 4 here, which is 3x plus 2y equals 2,875. And then if we take them away, we'll eliminate the y's. So let's do take away, subtract. So 4x take away 3x is going to be x. 2y take away 2y, so that's equal to 0. And then 3,600 take away 2,875 is equal to 725. So that means x, the cost of an adult season ticket, is £725. So let's write that down, £725. And let's just make sure we're answering the question correctly. Yep. So x is £725, so that's great. Okay, now I'm going to substitute that into equation 5. So I'm going to sub x equals £725 into equation 5. So if we put this into here, 2 times 725 would be 1,450 plus y equals 1,800. And then if we take away 1,450 from both sides of the equation, we'll get that y is equal to £350. And that's it. So y is £350, the cost of a child season ticket. And then if we go back up here, I'm going to substitute these both into equation 2 here. So I'm going to sub x equals 725 and y equals 350 into equation 2. So if I substitute these into equation 2, we'd have 725 minus 350 minus z equals 50. 725 minus 350 would be equal to 375 minus z equals 50. And then here we need to find out what z is. Well, we can add z to both sides and take away 50 and get that z's equal to 325. We can just look at it and say, well, z would be 325. So that means the cost of a pensioner season ticket is £325. £325. And let's check those. So let's check in equation 3. So equation 3, if we write down equation 3, so check in 3. So equation 3 is x plus 2y plus z equals 1,750. If we scroll back up, that's equation 3. And let's substitute these in and see what we get. So x is 725 plus 2y, that's going to be 2 times this, which is 700, plus z, which is 325. Does it equal 1,750? Well, let's have a look and see. Well, 725 plus 700 is 1,425. Plus 325 would be 1,750. So we get 1,750 equals 1,750. So we know we're correct. And that's it. Okay, let's have a look at our next question, question number 11. So question number 11 says, Oshin is training for a race, and as part of his training, Oshin completes 3 types of run: a short run, a medium run, and a long run. And we've been asked to let x, y, and z represent the length in kilometres of a short, a medium, and a long run, respectively. And in September, Oshin completes 24 short runs, 18 medium runs, and 6 long runs. And the total distance he ran in September was 450 kilometres. And we've been asked to show that x, y, and z satisfy the equation 4x plus 3y plus z equals 75. Okay, so let's form an equation with what we've been told so far. So Oshin completed 24 short runs, and each short run was x kilometres. So that means the total length of these 24 short runs would be 24x. He completed 18 medium runs, and each medium run was y kilometres, so 18 times y would be 18y. And he completed 6 long runs, and each long run was z kilometres, so 6 times z would be 6z. And then if we added them together, that'll be the total distance he ran, which was 450 kilometres. So let's do that. So 24x plus 18y plus 6z equals 450. Now if we have a look and see what we're trying to get to, it's not quite what we've got here, but we can actually divide the equation we've been given by a certain number to get to this equation that we want to show. And we can divide everything by 6, because if you notice we've got 6z and then z. So let's divide everything by 6 and see what we get. So on the left hand side we would get 4x plus 3y plus z. And on the right hand side, if we do 450 divided by 6, we get 75. So that's it. So we've shown that equation. And then if we carry on, we're told in October, Oshin completed 5 short runs, 15 medium runs, and 20 long runs. And the total distance ran in October was 615 kilometres. And we've been asked to show that x, y, and z satisfy this equation. Okay, so 5 short runs, that's going to be 5x. 15 medium runs, that's going to be 15y. And 20 long runs, that's going to be 20z. And then if we add them together, that's 615. So let's do that. So 5x plus 15y plus 20z equals 615. Now if we have a look and see what we're trying to get to, instead of having 5x, we've got x. Instead of having 15y, we've got 3y. I'm noticing here if we divide by 5, we'll get to this. So let's start. So let's divide everything by 5 and see what we get. 5x divided by 5 is x. 15y divided by 5 is 3y. And 20z divided by 5 is 4z. And then that's equal to 123. So that's fantastic. Okay, and then if we carry on, we're told in November, Oshin replaced the long run, so remember the long run was Z, with an ultra run. And an ultra run is 40% longer than the long run. So it's 40% longer. And then we're told that month he ran 14 short runs, so that's going to be 14x, so 14x because each short run was x kilometres. 4 medium runs, that's 4y, and then 10 ultra runs, covering a total distance of 420 kilometres. And we've been asked to show that x, y, and z satisfy the equation 7x plus 2y plus 7z equals 210. Now, one thing I've noticed here is that in terms of the ultra run, they haven't given us a new letter. We're still using z's, and if we go back up, z was the length of the long run. So z was the length of the long run. And here we were told that he ran 10 ultra runs. So not long runs, ultra runs. But we know that if the long run is z, the ultra run is 40% longer. So if we can increase z by 40%, that will be the ultra run. And to increase something by 40%, we use our multipliers. Think back to multipliers. To increase something by 40%, you multiply it by 1.4. If you multiply something by 1.4, you increase it by 40%. So if the long run is z, the ultra run will be 1.4z. So the ultra run will be 1.4z because that's the long run, but 40% bigger. So we don't actually need another letter. We just need to use this multiplier. Now, if each ultra run is 1.4z, then 10 ultra runs, well, if we multiply this by 10, so 10 times 1.4z will be 14z. So that means that he ran 14x, 14 short runs, 4y, which is 4 medium runs, and 14z, which is 14 times the distance the long run was. And that's fantastic because now we can form an equation that 14x plus 4y plus 14z is equal to 420, because we know if we add them up, that's going to be the total distance he ran. And then if we half all of that, we get 7x plus 2y plus 7z equals 210. And that's it. So that's fantastic. Okay, let's have a look at our next part. Okay, so we found our equations. Our last part then is to solve the simultaneous equations. Okay, let's see which letter we're going to eliminate. Now I'm thinking we eliminate y here because we've got 3y and 3y, so that's going to be quite straightforward there. And then with the 2y, we can treble this equation, or triple it, multiply by 3, and we can double one of the others and then take them away, and that'll cancel the y's as well. So let's sum up the equations, equation 1, equation 2, and equation 3. Okay, so let's do equation 1 subtract equation 2 to eliminate the y's. So let's do equation 1 subtract equation 2. So equation 1 is 4x plus 3y plus z equals 75. And equation 2 is x plus 3y plus 4z equals 123. Actually, looking at this with hindsight, perhaps I would have done equation 2 take away equation 1, but it doesn't really matter. So I'm just going to do it this way, but I could have done it the other way around. So it's really up to you. Okay, so let's take these away and see what we get. So subtract 4x take away x is 3x. 3y take away 3y, well, they're going to be eliminated. That's going to give us 0, which is what we want. And then z take away 4z will be minus 3z. And that's going to be equal to 75 minus 123. And 75 minus 123 is equal to minus 48. And if you did the subtraction the other way around, you would have got minus 3x plus 3z equals 48. Actually, both ways are totally fine. Okay, so that's equation number 4. I'm going to call that equation 4. I'm just going to put an arrow there. So that's equation 4. Okay, so we've eliminated the y's there. Now let's eliminate the y's using the other equation. So what I'm going to do is I'm going to multiply equation 3 by 3. That'll give us 6 y's there. So 3 times equation 3 would be equal to 21x plus 6y plus 21z equals 630. So we've just multiplied equation 3 by 3. Now I'm going to double one of the other equations. I'm going to double equation 2. So 2 times equation 2 is equal to 2x plus 6y, that's what we want, plus 8z, and that's equal to 246. And then we're going to take those two equations away from each other. So we're going to subtract there. 21x take away 2x, that's 19x. 6y take away 6y, that cancels out, which is what we want. And then 21z take away 8z, that's 13z. So plus 13z equals, and then if we do 630 take away 246, that's equal to 384. So that's equation 5. Okay, so that's great. We've now got equation 4 and equation 5. Now, the thing that I notice here is that we've got 3x and 19x and minus 3z and 13z. It's not an obvious number in terms of what we're going to get those variables to be whenever we are trying to eliminate them. Let's multiply equation 4 by 13 to get minus 39z, and let's multiply equation 5 by 3 to get 39z. So let's do 13 times equation 4. So 13 times equation 4 and see what we get. So if we times this equation 4 by 13, 3 times 13 is 39, so we get 39x. 13 times minus 3z would be minus 39z, and that equals, and if we do 13 multiplied by minus 48, that's equal to minus 624. Okay, so that's 13 times equation 4. Now let's do 3 times equation 5. So 3 times equation 5 and see what we get. So 19 times 3 is equal to 57x. And then we've got 13z. We're timesing that by 3, so that'll be plus 39z. And that's equal to, and if we do 384 times 3, that's equal to 1,152. Okay, so that's fantastic. We've now got our two equations, one with minus 39z and one with 39z. So let's add them together to eliminate those z's. So let's add them together. So if we do 39 plus 57, that's equal to 96. That'll be 96x when we add those together. These are going to add together to be 0. They're going to be eliminated, those z's. And then minus 624 plus 1,152 is equal to 528. And then if we divide by 96, that gives us an answer of x is equal to 5.5 kilometers. So it means that x is 5.5 kilometers, and that's the short run. The short run is 5.5 kilometers. Okay, that's fantastic. We found x. Now let's substitute that into one of the other equations, and I'm going to substitute it into equation number 5 here. Okay, so equation 5, I'm going to sub. I'm actually just going to change color of ink here just so it stands out a little bit so we know where we're at. So we're going to sub x equals 5.5 into equation 5. Okay, so this is equation 5 here. So we're going to do 19 times 5.5, and that's equal to 104.5. So 104.5 plus 13z equals 384. If we then take away the 104.5 away from 384, let's see what we get. So 384 minus 104.5. So we get that 13z equals 279.5. And then if we divide by 13, we're going to get that z equals 21.5. So z is 21.5. So z is the long run, that's 21.5 kilometers. Okay, then if we go on up, let's substitute those into equation 1. So let's sub x equals 5.5 and z equals 21.5 into equation 1. So 4 times 5.5 is equal to 22, plus 3y, and then we've got plus z, which is 21.5, equals 75. And then 22 plus 21.5 is equal to 43.5, and then we've got our plus 3y equals 75. If we take the 43.5 away from 75, so we do 75 take away 43.5, that's equal to 3y would be equal to 31.5, and then if we divide by 3, so if we then divide by 3, we get that's equal to 10.5. So y is equal to 10.5. So y is 10.5, the medium run. So we've got that a short run is 5.5 kilometers, medium run is 10.5 kilometers, and our long run is 21.5 kilometers. And we can check our answer. If we go back up and we substitute those into equation 2, and we do 5.5 plus 3 times 10.5 plus 4 times 21.5, and obviously you'd write all this down, you get that's equal to 123. So we get 123 equals 123, so we're nowhere right, and that's it. Okay, let's look at our last question. So question number 12 says a concert venue sells 3 types of tickets: standing, seated and VIP. And for each concert, the venue sells a maximum of X standing tickets, a maximum of Y seated tickets and a maximum of Z VIP tickets. And the venue can sell a total of 18,000 tickets for each concert. Therefore, X plus Y plus Z satisfies the equation X plus Y plus Z equals 18,000. So in other words, the maximum number of standing tickets plus the maximum number of seated tickets plus the maximum number of VIP tickets must equal a total of 18,000. Then if we go on down, we're told for a recent pop concert, 75% of the standing tickets, 90% of the seated tickets and 45% of the VIP tickets were sold. And a total of 15,600 tickets were sold for the pop concert. And we've been asked to show that X, Y and Z satisfies this equation. Okay, so 75% of the standing tickets were sold. Well, the maximum number of standing tickets that can be sold is X, and if 75% of them is sold, what we would do is we would work out 3/4 of that. And to find 3/4 of a number, you can multiply by 3/4, or I'm actually just going to write it as 0.75, because 0.75 times X is 75% of X. Okay, next, 90% of the seated tickets, well, there's Y seated tickets, and 90% of them are sold. So if you think of your multipliers, if you multiply something by 0.9, that tells us 90% of it. And then 45% of the VIP tickets, that's going to be 0.45 Z, because if you multiply Z by 0.45, you work out 45% of it. So that means that 0.75x plus 0.9y plus 0.45 Z equals 15,600. Now that's not quite what we're trying to show here. We want to show 5x plus 6y plus 3z equals 104,000. So what I'm now going to do is I'm going to multiply the whole equation through by 100. So that'll be 75x plus 90y plus 45z equals 1,560,000. Now I'm going to divide. If we have a look at the equation, we've got 5x. Well, to get from 75x to 5x, we're going to divide by 15. To get from 90y to 6y, we're going to divide by 15. To get from 45z to 3z, we're going to divide by 15. And hopefully if we divide this by 15, we're going to get this. So let's check it. Let's get our calculator and work that out. So if we divide everything by 15, we're going to get 5x plus 6y plus 3z equals, and then 1,560,000 divided by 15 is equal to 104,000. And that's it. So that's that equation. Okay, then if we carry on, we're then told for a recent rock concert, 4% of the standing tickets, 1/5% of the seated tickets and 52% of the VIP tickets were not sold. That means that 96% of the standing tickets, 4/5 of the seated tickets and 48% of the VIP tickets were sold. So we just need to be careful there with the were not sold. And we're told that a total of 14,640 tickets were sold for the rock concert. And we've been asked to show that X, Y and Z satisfies this equation. Okay, so we want to find out how many tickets were sold. So 4% of the standing tickets were not sold. That means that 96% were sold. And to work out 96% of X, we're going to do 0.96x. Because 4% were not sold, so 96% were sold. So that's 96% of X. Plus, then we're told 1/5 of the seated tickets were not sold. That means that 4/5 were sold. So there's going to be 4/5 of Y, or 0.8y, just changing it to a decimal. 4/5 is a decimal, 0.8 y. And then 52% of the VIP tickets were not sold. That means that 48% were. And if we do 48% of Z, that'll be 0.48 Z. And that equals 14,640. Now let's multiply the whole equation through by 100. So we're going to get 96x plus 80y plus 48z equals 1,464,000. And then we want to get 6x, 5y, and 3z. So if we divide these terms by 16, because 96x divided by 16 is 6x, 80y divided by 16 is 5y, and 48z divided by 16 is 3z. And then hopefully if we divide 1,464,000 by 16, we'll get this. So let's check that. So let's divide everything by 16 and see what we get. So 96x divided by 16 is 6x, 80y divided by 16 is 5y, 48z divided by 16 is 3z, and finally if we have our 1,464,000 and divide that by 16, we do get 91,500. And that's great, that's what we were trying to show, and that's fantastic. And then finally, part 4, we've been asked to solve the simultaneous equations to find the maximum number of standing, seated and VIP tickets available for each concert. So in other words, X, Y and Z. Okay, so let's start off with these. Let's see what we can eliminate. I'm looking here at the Z's. So let's multiply the top equation by 3 to begin with. So it's going to be 3x plus 3y plus 3z equals, and then 18,000 times 3. So 18,000 multiplied by 3 is 54,000, so 54,000. So I've just started off by multiplying equation 1 by 3 to get this equation, and I'm going to call it equation 4. Now what's great here is we've got 3 equations with 3z. We've got equation 4, equation 2 and equation 3. So I'm going to start off by doing equation 2 take away equation 4. So equation 2 take away equation 4. So equation 2 is 5x plus 6y plus 3z equals 104,000. And equation 4 is 3x plus 3y plus 3z equals 54,000. And then if we take them away, let's see what we get. 5x, let's write there, subtract. 5x take away 3x is 2x. 6y take away 3y is 3y, and the z's cancel out because 3z take away 3z is 0. And then if we have 104,000 take away 54,000, that leaves us with 50,000. So that's great, and I'm going to call that equation 5. Okay, now so we've done equation 2 take away equation 4. Now I'm going to do equation 3 take away equation 4. So let's do that as well. So equation 3 take away equation 4. So equation 3, if we have a look at that, equation 3 was 6x plus 5y plus 3z, I'm just looking at the question sheet here, equals 91,500. And then we're going to take away, subtract equation 4, which is 3x plus 3y plus 3z equals 54,000. And then we're going to take them away from each other and see what we get. 6x take away 3x, that's 3x, plus 5y take away 3y, that's 2y. And then the z's cancel, and that leaves us with 91,500 take away 54,000 is equal to 37,500. So that's great, and I'm going to call that equation 6. Okay, now if we have a look at equation 5 and equation 6, we want to cancel out the x's or the y's. I'm going to double equation 5, so I'm going to do 2 times equation 5. So 2 times equation 5 would be 4x plus 6y equals 100,000. And I'm going to do 3 times equation 6, so 3 times equation 6, 9x plus 6y equals, and I'm just going to get 37,500 and times that by 3, and that's equal to 112,500. And I'm going to number those equations. Equation, well, we've got 2, 6, so let's call that equation 7 and equation 8. And I'm going to do equation 8 take away equation 7. So equation 8 subtract equation 7 and see what we get. I'm just going to go down here. So equation 8 is 9x plus 6y equals 112,500. Equation 7 is 4x plus 6y equals 100,000. And then if we take them away from each other, subtract, we're going to get 9x take away 4x, that's 5x. And then that equals 12,500. And then if we divide by 5, we're going to get 12,500 divided by 5 is equal to 2,500. So that means there's a maximum number of 2,500 standing tickets sold for each concert. Now let's find y and z. So we know that x is equal to 2,500. So I'm going to substitute that into equation 5 here. I'm just going to change color ink here. So sub x equals 2,500 into equation 5. So if x is 2,500, 2 times that would be 5,000 plus 3y equals 50,000. And then if we take 5,000 off both sides, we're going to get 3y equals 45,000. And if we divide by 3, we're going to get that y is equal to 15,000. So y is equal to 15,000. So y is 15,000. The maximum number of seat tickets is 15,000. Now let's find Z, the VIP tickets. Now I'm going to go back up to equation 1 definitely there. So we're going to sub x equals 2,500 and y equals 15,000 into 1. And if we do that, we get, if we add them together, we get 2,500 plus 15,000 plus Z equals 18,000. And then if we work that out, we're going to get the Z is equal to 500. So Z is 500. So let's write that down, 500. And that's it. And we can check that. We can substitute those back into the other equations. We can substitute that into equation 2 or equation 3, and you'll find that that works. And that's it. And that's it. So these have been the video solutions for the Corbettmaths Practice Questions on simultaneous equations with 3 unknowns. I really hope you found this video useful. If you need any extra help on simultaneous equations with 3 unknowns, if you go to video number 393 on Corbettmaths, there's a dedicated video tutorial there on solving simultaneous equations with 3 unknowns. Alternatively, you can scan this QR code. And that's it. So I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. And also, if you know anyone that might find the Corbettmaths resources useful, whether that's the revision cards or the 5-a-day books or anything at all on Corbettmaths, please recommend it to them. That'd be quite useful as well. So thanks so much. Cheers. Bye.